All right. Hello. Doesn't work. What's going on here? All right, I have to use the keyboard. I hope you don't mind. So I'm Rodrigue Schaefer. I'm at Zalando for 2 years now, pretty much exactly. I started there as head of engineering for brand solutions, which is our B2B part. And I'm currently also responsible for the fashion store, so the online shop. Who of you does not know Zalando? I'm just asking because outside of Europe, we are not that well known. Is anybody here who doesn't know Zalando? Oh, okay, I hope the next 5 minutes are not wasted then. Our mission currently is connecting people with fashion. So we're not only an online retailer, we're a platform. We're in the middle of becoming a platform. We want to connect different parties who have something to do with fashion together. So for example, stylists with customers, factories, long tail, offline stores, everything, right? What some people might not know is that Zalando is quite huge. So we're not a small startup, we're really, really big. We were at one point the fastest European company to reach 1 billion revenue. I don't know if somebody else broke this record up until now, but at around 2011 we did it. We have 15 countries currently with around 17 million active customers, so customers who do something in the recent months, and around 3 billion revenue last year. We have 10,000 employees. Around 1,000 of them are working in tech, and we have 7 tech hubs all over Europe. So our newest additions are, for example, Dublin and Helsinki, where we ramp up quite a lot right now. So let's get to the beginning of Zalando. How was it? How did we become what we are now? And what led us to the choice of going with a microservice architecture. We started with a proof of concept in 2008 with Magento. Do you know what Magento is? It's like an e-commerce system which you might use. It's based on PHP. It's quite good for small retailers or mid-sized companies, but it doesn't scale very well. So when we did this proof of concept, selling shoes online, which was, at least in Europe, quite new, we had some success, which means that when we did TV advertisements, for example, we had trouble keeping the platform alive. And this led us to a point where we just couldn't handle the load anymore with the systems we had. This was in around 2010. So we even invited the CTO of Magento to help us with this, and everything which we tried, no tuning was successful. We just couldn't make it with this platform. So that's why we decided to build our own system, and we did so in around 3 months. It was at that time based on Java, Spring, and Postgres database. And yeah, coming from a situation where we experienced lots of instability and performance problems, our main focus at that time was, of course, to make the system as efficient, fast, and stable as possible. So we took a sort of defensive approach, right? A lot of the business logic was down in the database layer and stored procedures. The web developers could only access these stored procedures. They weren't able to access the database directly to modify rows or stuff like that. So we encapsulated this logic. This helped, but when you do this and you run with it for around 5 years and you add one feature on top of another feature, the thing becomes quite hard to handle. So I'm talking here about things like maintainability and extending the system with new functionality. And this was a point where we had to think about how we want to go forward. So we also saw some negative effects on, for example, productivity. So if you have a huge number of engineers working on the same code base, which is also huge, then you see a lot of dependencies between teams. So you need a lot more coordination, a lot more talking to each other to see that things can be released at one point in time, for example, if you go with a release train model. And this extra amount of coordination leads to, the law of diminishing returns, in the sense that if you throw more engineers onto it, it doesn't make the thing go faster. In fact, it slows everything down from a certain point on. We saw negative effects on innovation. So we know that as code size increases, bug density and complexity also increases, right? To have a stable system, you need then to introduce very rigid processes with quality assurance, also with release processes. Everything was tightly controlled at that time. So we tried to kill any kind of variance in the release process so that we can do it without running into problems all the time. And if you have these rigid processes, of course, you also kill sort of the innovation part of it, right? And in fact, of course, you have things like everything has to be the same technology, which is also not that nice in a tech environment. Last thing is we saw negative effects on growth. So we tried to hire a lot of people. And if you have an old tech stack, and I mentioned that in 2010 we chose the Spring Stack, right? Our front end was JSP based. We even had custom tags, right? This old stuff from 10 years ago. So in 2010 we chose a technology which was proven. So it was already a few years old. Now we have 2016. This tech stack is like over 10 years old. It's not very interesting for most young developers, right? If you look at people around 25 to 30 years old, how are the chances that they are really comfortable with this tech stack? It's tough. So we saw we are not very magnetic towards young talent. And also another bad thing is if you have a huge code base, the time to onboard new people takes ages. It's just the code is so big, they have to know everything, and they don't even have the confidence to change things in the beginning. Because, of course, everything you change can lead to a problem on the other side in some other team, and then everybody is pointing fingers at you. So this is quite bad. So after we saw these negative effects on our organization, we thought on how can we change this? How can we achieve something better from an organizational viewpoint and also from a technological viewpoint? There came radical agility. We worked on this concept for quite some time and rolled it out last year in March. What is it, or what do we want to achieve here? We want autonomous teams to deliver amazing products efficiently at scale. We want to take a team, put it, in a speedboat, and off you go. Good luck, right? We want them to be independent, to just create awesome stuff without having to look left and right all the time to see that they are not somehow having a negative impact on others, right? So radical agility is a concept which is based on 3 principles glued together by trust. The principles are autonomy, purpose, and mastery. Autonomy means that a team can act on its own. It can define its own, for example, software delivery process. It can define its own tech stack. It's cross-functional. It can do everything from having an idea, developing it, testing it, deploying it to live, and operating it. So it has full control. Purpose is something which you basically need to give the team so that everyone goes into the similar direction or into the direction which the company wants at that time. We have strategic alignment through giving all of these teams a definite purpose. We do this with OKRs currently. It's I don't know if you're aware, if you know this concept, but it's you can imagine it as some sort of pyramid. So the company defines its objectives for a year, then departments take these objectives and define their own, and the teams do the same. So everybody is more or less on the same page. We align each other to see if we need something from somebody else, that things are done in the same quarter. We also have mastery. So mastery is, first of all, something where we want to give our engineers a chance to get better at what they want to be good at, right? So if somebody really wants to become a database expert, we help them with this. We want excellent engineers, and that's why we need to put some effort into it so that they can grow and develop and just become good. Incidentally, these things are also dimensions coming from the field of positive psychology. I don't know if you heard about positive psychology. It's rather new. In the past, psychology always dealt with healing people who are sort of sick, right? And nowadays, we also think about how can we make normal people more happy. And RIF had, scientists had defined 6 dimensions. 3 of them are these. So mastery, for example, leads also to engineers being able to get into the flow and to forget time and just do what they like to do. Trust is very important here. All of these things wouldn't be helpful if, as a company, we don't give the teams the trust, if we don't believe that they do the right thing, right? But if we do, then they also trust us back, and it just works. Especially with more experienced engineers, it's really a great environment. I don't know why this is always stopping here, right? Okay, so now we get to the technological side. You will probably see this Conways law a lot today and tomorrow because it's, I don't know, it fits quite well. So if you change the organization, you have something like a reverse Conways law. So we changed the organization, and now suddenly the old tech landscape didn't really fit to the way we want to work together. So what's next? We need to change the technological landscape. And radical agility is combined of both parts, so the organization and the tech landscape. And that means for our purpose-driven organization composed of these autonomous teams, we need something similar on the tech side, which is a service-oriented architecture composed of loosely coupled services that have bounded contexts. This is the definition of Adrian Cockcroft from Netflix. He is here in this conference also, which is microservices. So both parts fit together to form radical agility. Okay, so I'm going to talk a little bit now about the challenges we've seen since we introduced all of this. We're around in the 9th month of this change. Right? One thing is operations. There is this famous quote from Martin Fowler with the prerequisites of microservices. So you need to have rapid provisioning, you need to have rapid deployment, and you need to have basic monitoring. This is really important because if you take a huge monolithic system and all the logic there and create microservices out of it, you basically push the complexity down to the infrastructure level. And that's why you need to be very good at this, at operations. This is how we are set up. So for provisioning, we use AWS. We use Docker for deployment. And for monitoring, we use AppDynamics and ZMon2. ZMon2 is something we developed ourselves. And all of this is held together by a framework called STUPS.io. It's open source. You can have a look. It's really neat. It allows teams to easily create new stacks on AWS to deploy their applications. And it also does a lot of other stuff. like, for example, allowing SSH access to the machines, creating audit reports, and also allow full AWS access. So the setup is like this. Every team has its own AWS access, and they can do more or less whatever they want with it. STUPS is there to help them easily deploy stuff on their stack, and to also track, for example, or to secure the access to the machines. Because we are a public company, we need to be compliant with certain things. We need to have something in place to track that. Another thing which is quite challenging is the mindset of your engineers. You have to look out for a few things here. One of them is to expect other systems to fail. So if you have 200 microservices or more, not all of them will be alive at the same time. It's quite unlikely. So your system just needs to be resilient to this. You need to cope with asynchronous communication. We need to use things like hysterics to block this domino effect if something goes down and all the other services then topple. This is something which most engineers who have not worked in a microservice environment before don't really know, or are at least not used to. So it's easy to forget. And if only one team forgets this, you have a huge problem, right, in productivity. So it's very important to remind the teams all the time about this. Another important thing is the end-to-end responsibility. I talked a little bit about this autonomy. So we have these cross-functional teams, and they're really responsible for everything. So there is no, I code something and then I throw it over to QA and be done with it. They have to do QA themselves, which means they have to learn how to have good test coverage, how to automate tests, right? How to be confident in what they do. They also have to learn DevOps, so they have to operate the things, their services, on their own, which is also something which not all engineers know about. So these are things which we need to teach them. We have the setup in a way that teams should think as a small startup. So that's, I think, a good metaphor. If you're a small startup, nobody else takes care about your stuff. You have to do it yourself. And that's the same with the teams. They have to see themselves as a small startup. They have to see their products as software as a service, and the other teams basically as customers, right? And also quite a mindset change for a lot of people. API first is another thing. This is maybe doesn't fit exactly here, but API first is an approach we did to align on how our APIs over the around 70 teams look like, so that not everybody is doing something completely different, and in the end, it looks like a mess. We want to have coherent APIs all over the place, and for that we are also doing things like reviews through an API guild, which is set up with a lot of volunteered engineers. This is a bit annoying. Sorry for that. I'm offline. Damn it. Okay, global architecture, another big topic. So if you have these around 70 teams and everybody does his own stuff, how do you make sure that things fit together in the end, right? It's tricky. A few things here. First thing we created was a document called Rules of Play, which defines, you could say, a vision of the architecture we want to have. So we defined some concepts there, like loosely coupled services, resilience, right? How APIs should be defined, that we want to use REST, for example. The stuff about the software as a service, as a mindset. So all of this was written down in a short booklet and given to everybody, so that everybody knows what we would like the architecture to look like in the end. We have peer reviews. So for nearly everything we do, you can go to a peer, ask them to look over it, and just get some opinion if what you're doing is good or not, right? Or if there is just another alternative. We have TechRadar, which is looking at newest technologies and existing technologies and is trying to put them into different segments. So something, for example, technologies we don't really want to see, technologies we think are very nice but also very experimental, technologies which we know work and where we have competence in, so that if a team, for example, has to decide which way to go, it can also just think about how many people could help me if I have problems with this, right? So that's advice we give. We also have a shared concept of core business entities and also something like a prototype architecture. That's a system we set up during, I don't know, around 6 weeks last year, where we took some of our most brilliant engineers and put them together to create a blueprint of how the new microservice platform could look like. They took the most important parts of the business, created a dozen microservices, and created, for example, message queues, and showed how things could look like in the end. This is not an ivory tower architecture, it's just an idea. We presented this to the teams, and the teams more or less could just take what they found useful and go from there. Okay, compliance and security. So we went public, which means we have auditors who come to our office and need to check things, right? We need to make sure that everything is fine and the auditors are happy. And of course, we need our systems to be secure. So things like 4I's principle still needs to be somehow enforced. Currently, we do it mostly through our ticketing, but soon STUPS.io will also support this with an application registry, with signed application versions and stuff like this. So we have it automated. We have the audit trails with STUPS. We have created a new identity and access management solution. So it's not our own, we just introduced it, but it was a huge project and it's still ongoing. We want everything to be using this IAM solution. And yeah, we're currently in the phase of rolling out the first bigger service using that. So this solution from ForgeRock will basically allow customers to authenticate, but also internal employees and service to service, everything covered there. It's based on OAuth. Yeah, and also another interesting topic here is if you're a German company or European company and you go to AWS, you have to negotiate a data protection agreement. This takes a long time. Just if you convinced your managers to do that, we took, I don't know, at least 2 months for this. Sorry for that, I don't know. What's going on here? Okay, so last part is a case study on our fashion store. Fashion store is an interesting topic here because if you look at microservice architectures, you usually only look at the backend services, right? And that's kind of simple. So there are services, they have an API, they talk to each other. But what if you try to take this concept and move it to the front-end world, where everything comes together in one page? How do you split this up? How do you enable teams to be independent of each other there? How do you do stuff like, let's say, styling? I don't know if you're used to CSS. Usually, companies have something like a global CSS file where every style is defined in, right? How do you split that one up? How do you do it in a way that teams don't override other team styles and stuff like that? So I'll just introduce our new shop architecture. We're currently in the middle of rewriting the online shop. The online shop is one of the most important things we have at Zalando. It's responsible for around 95% of our revenue, so you can imagine that things should ideally go smoothly here. We have these different teams in the shop. There are around 12 teams. And we decided that teams will own fragments. A fragment you could think of as some component or widget on the page, right? Different things. Let's say the recommendation part. So this small box with articles recommended to you as a customer. These fragments are markup, right? And they're served by web apps operated by the teams. These web apps are on top of a microservice layer, which has all the business logic needed to create these markups. These microservices could connect to some storage. They could connect to other microservices, everything needed to fulfill its purpose. And when you have all these puzzle pieces, you have to stitch them together, right? So that's why we created a layout service. The layout service calls all needed components for a page and puts them into a provided template. The template is based on the URL, and it also takes the context. The context could be, for example, you as a user, right? And then it creates the page itself by calling the endpoints, putting things together. And we also use this big pipe concept here from Facebook. So we're flushing a component to the user's browser immediately when it's ready. There are a few tricky things here. For example, how do you define the response code of the page if you only know the components? And we have to send the response code immediately. So what we did here is we define one component as a primary or as a defining characteristic of a page and try to render that first. And if it is good, then we send 200 and we were fine. We have a router in front of this. The router is needed because we want to have a smooth migration from the old shop to the new one. This is quite, I mean, you can imagine that creating a big bang change to a new shop architecture is somewhat risky in this context, right? So that's why we go page by page. We're starting with the most critical thing you could do. We're starting with the checkout. And we're currently in the middle of rolling it out. So what we have is a router which can route traffic to the old shop, but which can also route traffic to the new shop. We can do it gradually. So we can say, okay, for Italian customers, 3% of traffic now goes to the new page, right? And the rest goes to the old. We can do A/B testing here, so we can be careful in rolling out things. The router itself resembles a little bit the controller part of an MVC application. So you have all these routes. We can filter requests. We can change them. We can do a lot of stuff there. And of course, it has a storage of all the routes. Interesting thing here, we can add or change routes dynamically on runtime. So that's also quite useful for the teams, because if you are a team and you just want to have a new page or have a new feature live, you can just call the API to this and add this route and you're done. You can do it without redeploying anything else except maybe your own system. If I talk too long, this thing freezes. Sorry. Okay, we've done this as open source. So if you're interested in how this microservice architecture could look like in a front-end environment, check these projects out. Skipper is the router. It's live already. Tailor is a layout service, also live. Innkeeper is the system which manages all the routes and which has an API to modify them. Quilt is the template storage, and will maybe, in the future, we are not 100% sure about this, also include the context stuff for a page. Yeah, and as I said, there will be soon in production all of this. And if it survives Zalando, then maybe it could also survive your traffic, depending on what you're doing. This is amazing. All right. So, what does that mean for all these things we looked at? Innovation, productivity, and growth. So, innovation, we are now able to inject new features on the fly during runtime. We have very fast feedback loops through this. So if you're a team and you want to try out stuff, you can do it. You don't have to wait for some release train to happen next week, right? If you're lucky and it doesn't get postponed, you can do it all the time. It's tech agnostic. People can try out new technologies if they want to. The productivity is enhanced because teams have now full control. They can define their processes as they want, tailor-cut to their needs. So it's more agile, more lean. The whole development deploy cycles are completely independent between the teams. And they can now really go for continuous delivery. Some teams do it already, others not, but it's possible. And this will also help the teams to move forward more quickly. Right? From the growth perspective, every team now has a way smaller code base. It's very easy to onboard new developers. We've seen this already happening for quite some time. So developers are ready to go after a few weeks and really are productive there. The up-to-date tech we're using and also this new shop architecture is interesting to most people, especially front-end engineers. But also in our platform teams, the option to develop something in Scala or in Go, this is really something which a lot of engineers like to do. So, good thing. And also it's very easy to spin off new teams due to this architecture. We can easily just take 5 people, put them together, and have them build some new feature for the shop without impacting others. So that's all of this is it's quite positive for our culture there and for the way we work, right? And yeah, that's it. So now we're sort of putting all these puzzle pieces together. We're trying to roll out the checkout soon. And we're starting a big journey. So we are not at the end yet. It's an adventure, if you will. And it will probably take this year to migrate most of the systems we have to this new architecture. Yeah, that was it. Thank you for listening. If you have any questions, please.
Thanks for the presentation. How do you manage the balance between giving independence to the teams and avoid having teams working on the same stuff and solving the same problems, maybe with even different technologies? You know what I mean?
Yeah, I know. It's a valid point. So teams are not completely without leadership. So we don't have a leader inside a team, but we have people we call delivery leads. Delivery leads you could think of as being also sort of a coach for teams. They have a bigger picture of what the company is building right now. They can connect teams with each other if they see synergies, for example, and can make sure that the necessary information, the necessary communication happens, right, between the teams. But you're right, this happens with a lot of teams, and we try to be aware of these things and try to get people together.
You briefly spoke about implementing the IAM solution currently you're working on. What are the challenges you're having with that? Because you said it takes some time to actually get it rolling.
Okay, so our current challenge is scaling to handle all these requests we have. So, as I said, we're starting with the shop. We have a lot of requests from customers, and this multiplies. So if a customer calls our service, and then our layout service starts to call a dozen endpoints, and these endpoints then start calling another dozen microservices in the platform. Each service has to authenticate with the other service, and everything is currently done on the IAM level. So scaling this is really tough. And it's very hard to calculate what scale we need up front.
Hello. My question is, how much time takes this migration from monolithic application to microservices? Yeah.
Okay.
Yeah,
I don't really want to give a deadline here because otherwise, no. But it takes a long time. I can tell you for the shop. So we started defining the new architecture in summer last year. I think we might be at 90% of the migration maybe at the end of this year. So just to give some scope to this, right? With the platform, it's, I can't really say.
But it's not an easy task. You should define some stuff in order to, it's not something which is easy to do.
That's correct. It's not easy.
Okay.
Yeah.
Hi, great talk. How you doing? One thing I was really interested in, you mentioned about a sort of document that defined some guidelines perhaps and a tech radar, that kind of thing, which I think is really interesting and a lot of companies are trying to do that. Is yours available sort of open source? Are you planning to share that kind of document at all?
Good question. I think currently it's not open source, but we might have some blog posts on this on our tech blog. So take a look there. And if it's not there, I will definitely try to ask for it there.
Hi. So my question goes into a similar direction. How do you organize to come to an alignment regarding, for instance, architectural principles? And also, I guess, on the front end, it's even more difficult. You cannot have the whole choice, like in the back end, of different languages. You're limited probably to certain frameworks. So how do you align this with so many people and teams organizationally?
Okay, so in the back end, as the services are tech agnostic, teams can more or less choose whatever they want, but you're very right, in the front end it's a little bit different, because if now every team starts to take some fancy JavaScript framework and puts it there, this stuff lands or ends up in the user's browser. And this means also more loading time, for example. This means maybe incompatibility between JavaScript frameworks could lead to a mess. So in the shop, we decided on a list of things we allow. And we decided with the front-end engineers all together on this. So that was sort of an alignment we had to do. Yeah, the rest is handled more or less with TechRadar.
Hey, hi, over here, to your left, I guess. Here. Question is, like you said, you're rolling out the new checkout, and my question is, like, does the old shop monolith still have the checkout, or is that something you like ripped out and turned into a microservice, or is it a complete rewrite?
It's a complete rewrite, so both systems will run in parallel for a time. We will have a fallback through that, so if we see the new version is maybe not that stable or something, we can just switch back to the old one.
Can I do a follow-up onto that? Question is, why didn't you like turn the existing one into a microservice instead of just rewriting it?
In fact, it was too difficult.
Okay.
As I mentioned, we had the shop for quite some time. We had these 5 years. And especially the checkout, if you think about moving into another country, for example, the checkout is a place where most changes have to happen. You have things like new delivery options, you have things like new payment methods and stuff like that. It all comes down into the checkout. So the old one is quite a mess, and that's why we created it completely new.
Hello, question over here. I'm excited that you open sourced a number of your components. What motivated you to do that?
To go open source?
Yes.
First of all, we believe in open source because we use open source ourselves. And we also want to give something back to the community. And not only that, by providing interesting open source projects, we position ourselves as a tech company. And this is for us important because a few years ago, nobody really thought about Zalando as a tech company, but this is what we are, in a sense. And in the beginning, I said we have around 1,000 people in tech. That's not a small number, especially not for Europe, right? And we want to show it.
Hi. What's the size of your teams?
We follow this Amazon 2-pizza rule. So team size is between 2 and 12 people, but most teams are around 6 people.
How do your teams share code? Do they copy-paste it or publish libraries, or do they just share the ideas?
Okay, so we don't really use shared libraries. If you have a library and you want other teams to use it, you have to publish it as open source. Then it's okay. But it's a tough thing, in fact, due to the dependencies it creates if you have shared libraries all over the place. But open source is the only option there, which we allow.
Me again. Are you still having a central operations team that is dealing with all those microservices, or did you actually convince the development teams to actually do on-call for their services?
Differs. So right now we still have a 24/7. We have a first-level support team who just tries to handle any incidents which come up. But we will move into the direction of teams being responsible for their own systems. We have some teams doing this already, but really only a few.
Yeah, hello. How do you realize or implement things like performance tests, which are not only related to one team, but to the whole platform, the same as security patterns and the like? Is there also a team which works, let's say, somehow horizontal?
We have a business assurance unit, which, looks for these things, which also coaches teams on how to do such testing. And so there is a horizontal unit responsible for that.
One question about the teams and scaling the teams. How do you decide when the team limit is reached and a point is given time to split out a new team?
Okay, chances are that if your team is growing too big, then you have either created a service which is too big, or you have too many services, right? And in both cases, it's a good idea to either to split the team, so one half of the team could take care of half of the services, or if you come from you created the biggest service possible in that team, then you have to think about how you can split up this service again and move responsibility.
So I would say like 2 or 3 more questions.
Thank you for the presentation. My question is about the teams. Is the same team responsible for the same part at the monolithic and also developing the same part as microservice, or are you totally assigning new people for the microservice?
Currently, it's the same teams. So the team responsible for the product detail page, for example, is responsible for the old monolithic part of it and also for rebuilding it for the new shop architecture.
Hey, you talked about your case study and you showed how you split the team and having a front-end component in there itself. How do you deal with different clients? Like there are different front-end clients like mobile and stuff like that. Do you have a different API which wraps the microservices for them, or do you plan to consume it from there directly, from like iOS client, I guess?
So this was not really about mobile. While our architecture could be used for mobile too, the stuff I've shown now was built more or less for the web. So what we are currently thinking about is that instead of fragments being markup, they could also just be, for example, data, which could then be used by the mobile app to build its own view. But we haven't tried this out yet. We probably will midterm and see how that goes. Currently, mobile is based on the mobile API, which is in turn based on the monolith.
Hi, thank you for the great talk. One question regarding AWS. How do you deal with costs on AWS? Because basically every team decides what is their architecture and how much money are they spending. So how do you deal with that?
Yeah, good question. In fact, the responsible person is somewhere here. Right now, we track the costs, but we didn't yet limit costs to a certain amount per team. So we're looking at how much does a team spend, and if it seems a lot for what they are doing, we will look into what kind of instance types do they use, for example. Did they over-provision or not? And we will try to find a sweet spot there. Right now, when you do this migration, the teams are a little bit, when provisioning instances, a little bit defensive. So they try to provision probably more than they have to, just to be on the safe side.
All right, thanks a lot. Time's almost up. I think Rodrigue is like around for some time.
Yeah.
So thanks a lot for the talk.
Thank you.